Hello friends, Mr. Burrell here. We're in the middle of our statistics unit. We've talked about kind of the groundwork, the framework for statistics. We've talked about identifying like a population and the sample that we want to collect information from. We've talked about different kinds of studies and different kinds of variables that we could be, different characteristics of a population that we might be wanting to look at and analyze. We just finished in section 2 talking about different ways that we can get a sample from a population, different sampling methods, and how we can identify bias from creating that sample or from responses, how we can recognize if a study or a research project is biased. So now we're going to kind of talk about, now that after I've collected all this information, after I've collected all this data, what do I do with it? How do I know if it's significant? How do I know if it's important? How do I know what to do with this information and how to convey that information to other people? That's what we're going to be talking about today. So we're going to start talking about that by talking about histograms. This may be a term that you've kind of been exposed to before that you may have heard of. We're going to talk about what they are, how we can make them. So by the end of this lesson, this is what you will be able to do. I want you to be able to construct a frequency histogram and understand what a histogram represents. So we're going to construct these histograms and then talk about what those histograms mean. So before we get in here, I'm going to pull up this Excel book. So over here I have all these different numbers. I have copied these numbers from the survey. I sent out a survey to students, gathering some information about them. Hope you might be one that filled out the survey. And these are all the numbers of different students' shoe size. So I gathered, using a survey, information about the shoe size of a bunch of different students. So I have like this wide range of different shoe sizes. I have like 8.5, 9, 10.5, down to 7, up to like 11.5. I have a bunch of different shoe sizes. So looking at it right here, that just looks like a bunch of numbers. I don't really know what that means. Do people in my classes have big feet? Do they have small feet? Do they just have average size feet? What's going on? So a way that I'm going to be able to visualize that information in a helpful and accurate way is using a histogram. A histogram is a graphical display where the data is grouped into ranges and then plotted as bars. So a histogram, you might be thinking of this, might look something like this. This would be a histogram. It's a graphical display where the data is grouped into ranges and then plotted as bars. So some general definitions when it comes to making these histograms I'm going to cover briefly, and then I'll talk about when we're making our histogram. Left endpoint convention. If a data value falls in the division of two intervals, it is put in the interval or range that has that value at the left or beginning endpoint. If the data value was 4, for example, and I have two intervals that I'm concerned with, like numbers 0 to 4 and the numbers 4 to 8, the data value would be put into this interval because 4 is the left endpoint. So we'll talk about that a little bit more in a minute, but that's the left endpoint convention, just as a general rule when I'm creating these histograms. Relative frequency is the frequency of an interval in a data set divided by the total amount of data points. So relative frequency is how many times the frequency of an interval in a data set divided by the total amount of data points. I'll talk about that in a minute too. Percent frequency is the relative frequency multiplied by 100. That gives me the percentage in each of these intervals. And then skewness is asymmetry, so something that's not symmetric in a statistical distribution, to the left or to the right. Or in other words, the distribution has a tail. So all of these definitions probably don't make a whole lot of sense right now, but as we go through the creation of an actual histogram, I'll reflect and come back to these different points. So some histogram humor for you. Sitting in statistics class, keep hearing Instagram instead of histogram. Such a struggle. What a mess. Okay, so this table, I'm going to create this little table here. This table is going to summarize the shoe sizes in our class. And then I'm going to find the relative and percent frequencies, and then I'm going to make a histogram. So first of all, I have these different intervals. So these intervals, this is shoe sizes between 6 and 7, shoe sizes between 7 and 8, between 8 and 9, 9 and 10, 10 and 11, 11 and 12, etc., etc., etc. So I'm going to divide all of this information, all of those shoe sizes that I gathered, into these specific intervals. And then the frequency is going to be how many shoe sizes I have in those intervals. So let me pull up my thing here. And let me go ahead. I've highlighted all these numbers, and I'm going to go ahead and right click. I'm going to sort from smallest to largest. So now I can see all of these shoe sizes in order from smallest to biggest. So notice I have like 5 size 7s, 4 size 7.5s, 6 size 8s, 3 size 8.5s, 3 9s, 2 9.5s. This is like 7 10s, a 10.5, an 11, and 2 11.5s. So those are all our data points. So in my table here I have the intervals from 6 to 7, from 7 to 8, from 8 to 9. As you're looking at your guided notes, up above this table, I have, you can reflect back to that definition of the left point convention, the left endpoint convention. So for example, if I have a data value, if I have a shoe size of 7, which one of these intervals do I put it in? Well, I put it in this interval because 7 is the leftmost endpoint. 7 is the first number here. If I have a shoe size of 8, I'm going to put it in this interval. A shoe size of 9 in this interval, 10 in this interval, 11 in this interval, 6 in this interval, etc., etc. So let's look at my data here. I don't have any size 6s or 6.5s, so there's going to be nothing in that first row, but I have 9 data values between 7 and 8. My 7s and 7.5s. I have 9 data values. So back on here, I put a 0 here, and I'd put a 9 here. There's 0, 6s to 7s. There's 9 shoe sizes between 7 and 8. Let's look at the interval between 8 and 9, with 8 being the endpoint. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have 9 of these as well. So I'd go back and you can click pause on that Excel sheet and you can kind of fill in the rest of these dots, but I have all the information here. I have 5 shoe sizes between 9 and 10, 8 shoe sizes between 10 and 11, 3 shoe sizes between 11 and 12. Adding all those up, I get a total of 9 plus 9 plus 5 plus 8 plus 3, which is 34. There are 34 people in my sample that gave me their shoe sizes. Okay. So now the relative frequency, again, reflecting back to the definitions I covered just a second ago, the relative frequency is the frequency of an interval in a data set divided by the total amount of data points. So like here's the frequency in this interval, 0. So I'm going to take 0 divided by 34. That's going to give me my relative frequency. In my calculator, in my calculator, 0 divided by 34 is 0. There's 0 of them, so my relative frequency is 0. Here I'm going to go ahead and take 9 divided by 34. 9 divided by 34 is like 0.26. 9 divided by 34 again is 0.26. I'm going to write in all these other ones. 5 out of 34, 8 out of 34, 3 out of 34, and I'll write down what each of those relative frequencies are. 5 divided by 34 is 0.15. 8 divided by 34 is 0.24. 3 divided by 34 is 0.09. So if I were to add all these up, hopefully 0.26 plus 0.26 plus 0.15 plus 0.24 plus 0.09, that should add up to 1 whole. So that's my relative frequency, the frequency of each of these intervals divided by the total. So now let's find my percent frequency. If I go back here, my percent frequency is the relative frequency multiplied by 100, so it can be written as a percentage. So on here, if I multiply each of these by 100, 0 times 100 is still 0. 0.26 times 100, if I move that decimal place over 2 spots, I get 26%, 26%, 15%, 24%, 9%, and hopefully that will all add up to 100%. So, taking a look at this table here, about 26%, or about a quarter, of all of my students who filled out this survey have shoe sizes between 7 and 8. And then about 26% of my students have shoe sizes between 8 and 9. only 9% of my students had shoe sizes between 11 and 12. So a smaller amount of my students have really big feet, and a really small, 0% of my students had really small feet. So that's kind of analyzing this information. This table helps me to see, okay, what proportion of my class has these different shoe sizes? Okay. So now, with these different frequencies, with this information, I'm now going to make a histogram. So again, histograms are a visual representation of a data set. They are similar to bar charts. You may have been exposed to bar charts in math classes, but these are used only for numerical variables. The x-axis of a histogram is a series of intervals that groups the data, and the y-axis is the frequency. So this side over here, this is going to be the frequency. Don't mind me as I turn my head. This is going to be the frequency, and these over here are going to be the intervals of the shoe sizes. So I had like intervals from 6 to 7, from 7 to 8, from 8 to 9, from 9 to 10, from 10 to 11, and then from 11 to 12. Those were my intervals. So histograms can be helpful in interpreting data. What can I conclude from this information that I gathered from my sample? How spread out is the data set? Or where is most of the data located? So let's draw my little graph. I'm going to draw up the side here. I had up to about 9 in each category. So I'm going to go ahead and make little marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1, 2, 3. On my frequency, this is how many shoe sizes fell in each of those intervals. So in the 6 to 7 interval, there were 0. So I'm going to put nothing there. In the 7 to 8 interval, there were 9. So I'm going to write a bar right up here all the way to 9, right back down. In the interval from 8 to 9 shoe sizes, that was 9 again, so I'm going to write that right up there. From 9 to 10, there were 5, so I'm going to write right here. From 10 to 11, there were 8, so I'm going to come back up to here to go up to 8, and then from 11 to 12, there were only 3. So it looks like right here. So this would be a histogram that represents my data. Again, this is data, a sample that I collected from our classes. This is 34 kids from my classes and their shoe sizes. So this might be a pretty good representation of the shoe sizes in this class, or in this grade maybe. So what can looking at this histogram, what are some of the things that I can determine? Well, I can kind of determine that most of my students have shoe sizes between like 7 and 9. See that? Between 7 and 9, it looks like that's where most of the shoe sizes are. There are less people that have like really big feet over here in the 11 to 12 category. There are even less people, this is kind of curious to me, this is interesting that so few people had shoe sizes 6 to 7. Not very many people had really small feet in our class. Then we kind of had a drop between 9 and 10, and we had a hop up again to 8 people who had shoe sizes 10 to 11. So I can kind of analyze and look at what's happening, make some conclusions based on this visual representation. In research that people do, a lot of times this is how they present their information to people in the public, because lots of people can feel more comfortable reading information like this, like in a chart or in a graph, rather than just like text and numbers on a page. That's why you see lots of these like on the news, or you see them on the internet, because they're easier for people to analyze. So I want you to think about, just for a minute, we're going to get to this in the next section, so I want you to think about, if I, instead of just having 34 people in my sample, say I was able to get every single student in the school to respond to this survey, every single student, so like 1,500 kids, what do you think this histogram would look like if I had 1,500 kids respond to my survey? I want you to think about what the shape of this histogram would look like if everybody responded. So just be thinking about that. Have that on the tip of your tongue, in the back of your brain, something to nibble on for the next video, for the next lesson. So talking about histograms, we need to talk about skewness. So again, skewness is when my graph is skewed one way or the other, or if there's like a tail. So you notice like right here, this middle graph is really nice and symmetric. If I were to fold that graph in half, it would fold right over on top of itself. Most of the data points are in the middle, and there's fewer of them over on the edges. But if I look at, say, this graph, notice how if I were to fold this right down the middle, it wouldn't quite fold in half. There's almost like a little tail over on this side. On this graph, I have a little tail over on this side. So it's not really symmetric, it's skewed to one side. There's more data values over here on the left-hand side, or in this case, there's more data values over on the right-hand side. And then there's less over in this little tail. See that? So again, let me go all the way back here. Skewness, again, is asymmetry, or something that's not symmetric in a statistical distribution, to the left or to the right. So, like in this graph, I would say, in this histogram, I would say my data is skewed to the right. My data is skewed in the positive direction because I have this tail in the positive direction. On this histogram, I would say my data is skewed to the left or in the negative direction because there's a little tail over on the left side. Here's some histogram skewness humor for you. Negatively skewed, I have a tail on the left-hand side. Positively skewed, I have a tail on the right-hand side. This guy's really happy. This guy's really sad because he's negative and he's positive. But that's what a positively and negatively skewed histogram or set of data would look like. It's when I have a tail on one or the other end of my data set. So now let's look at an example of a histogram. So here it says the histogram to the right shows data regarding the amount of quality defects at a manufacturing plant. So during the 12 hours in the day, so here's like hour 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 all the way through 12. So there's 12 hours in the day. At each hour in the day, during each hour, they count how many quality defects they catch in their manufacturing in that hour. So say the day starts at 7, ends at 7 at night. There's 12 hours. Every hour, they count the number of quality defects that they find in this product, whatever they're making. They count the number of quality defects. So how many quality defects were in the sample? Well, let's see. Here it looks like there was 1. So there's 1 quality defect here in the second hour. Looks like there's 16 here. Looks like there's like, I don't know, 7 here, because these are the frequencies, right? So there's about 7 here, maybe about 9 here. Looks like to be about 12 here, about 7 here. Here there were 10 quality defects in the 8th hour. Right here it looks like there are 8 quality defects. Here it looks like 4, maybe 2 quality defects here, maybe 1 quality defect here. So those are the number of defects in those specific hours. So there's 1 plus 16 plus 7 plus 9 plus 12 plus 7 plus 10 plus 8 plus 4 plus 2 plus 1. That's how many quality defects we had in our sample. That's how many quality defects we had over the course of the whole workday. So 1 plus 16 plus 7 plus 9 plus 12. I'm just typing these in my calculator. Plus 7 plus 10 plus 8 plus 4 plus 2 plus 1. 1, 16, 7, 9, 12, 7, 10... 8, 4, 2, 1. I had 77 total quality defects in my sample. So at which hour were the most quality defects? Which hour between 1 and 12 of the day were there the most quality defects? Well, right here in hour 3 of the day, in the third hour of the day, there were 16 defects. So at hour 3, there were 16 defects, 16 quality defects that were identified. And then part 4 says at which hour were there the least quality defects. So it looks to be either one of these, right? Either in the 2nd or 12th hour, at the very beginning or very end of the day. In hour 2 and hour 12, there was only 1 defect found. There was only 1 quality defect found. So that's how I kind of look at these histograms and analyze this kind of information. I can look at this graph and I can get a lot of information just from this graph. There's a lot of stuff, a lot of data put into this one graphical representation. I can learn a lot about what's going on, in this case with these quality defects. So just some other examples of histograms. Here's a histogram of ages of people on TikTok. So like here's the ages down here, the categories on the bottom, and then on the left I have their frequency, or how many people fall into those categories. So there's 392 million 13 to 18 year olds that are on TikTok, 208 million 19 to 24 year olds, 196 million 25 to 34 year olds, and apparently there's no one over the age of 34 on TikTok. This might be a little bit older of a graph, I don't know, but that shows you that mostly teenagers on TikTok, right? Mostly teenagers on TikTok. Here's a histogram of earthquake magnitude. So like they measure earthquake magnitude based on the Richter scale, right? So it looks like most of my earthquakes fall right in like this category, between like 1.4, like 1.5 and 2 in magnitude. And it seems like there's fewer really large earthquakes. We have like one all the way out here, like one really huge earthquake. But it looks like most of my earthquakes have a magnitude between like 1.5 and 2. This is a histogram of ACT scores. So I have like this many people who score between 9 and 12, between 12 and 15, 15 and 18, 18 and 21, etc. So you can kind of see most people score like between 21 and 27 on the ACT. Mr. Burrell is right in here. Down here, there's much fewer that get like less than 15. There's fewer that get like above 33 up into the 36 category. But most people are like kind of right here in the middle, between like 21 and 27. That's some of the things that I can identify from this graph about people and their ACT scores. So that's all I want to talk about histograms. Histograms are a really valuable way of displaying data and displaying information. It's a really convenient way for people to analyze and see your data and kind of tell what's going on. It's a really good way for you to present, this is what I found. This is the information that I've gathered, and this is what it says. This is what it means. So hopefully by the end of this video, you're now able to construct your own frequency histogram and understand what a histogram represents and be able to kind of read and analyze histograms. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.